Okay. So this is where we left off yesterday. This should already be filled in the notes, so it shouldn't be a big deal. When you're going through what you use to prove stuff congruent, all right, I would look for angle first, since that's the easiest one to do. All right. After that, look to see if all three sides are proportional using extended proportion. If so, then you would use side theorem. See if two sides are proportional, and then check to see if the angles between them are congruent. If so, use side angle side. All right, so that's just a checklist. The order I would suggest isn't mandatory, but it's the idea behind it. Okay, so determine whether the triangles are similar. If so, write a similarity statement and name the postulate or theorems you use. If not, explain. All right. All right. So again, our choices are angle, side, side, angle, side. All right. Are they giving us any angle measures? No. Are they giving us any vertical angles, parallel lines, anything like that? No. But there is reflexive property. Why? What angle is shared by both the big triangle and the little triangle? Times with Q. Q. So Q is a shared angle. All right, so these are overlapping triangles. It may be beneficial to draw them separately. So QUR is the smaller one. QTS is the bigger one. All right. So I got angle Q. All right, but angle's out. Do they give me all three side measures? No. The side is out. All right. So I'm left with side angle side. I got the one angle, so now I got to work on the sides. So that's 2, that's 3. All right, that's 2, that's 3. All right, and now here's the idea. That's 8, and that's 10. Everybody understand that part of it, the 8 and 10? All right, so now I'm going to set up a proportion, 2 over 8 versus 3 over 10. All right, if you want to show the math, you can. Or if you do it in your head, for example, 2 over 8 reduces down to 1/4, right? Is 3 over 10 reduced down to 1/4? Nope. So they are not equal to each other. So therefore, no. And that's a good enough explanation for me, is showing the proportion. All right, so if you explain why, you're good to go. All right, number 2, are they giving us any angle measures whatsoever? No, so what's it got to be? Side. So give it a whirl. See if that's going to be similar by side. All right. Okay, so me, I'm going to take ABC and go from least to greatest. All right, just the way I do it. So 12, 30, 36. Then I'm going to go to NOP and do the same thing. The least is 8, the middle is 20, and the greatest is 24. Okay? You can either reduce them all, or you can cross multiply. 12 times 20 is 240, 8 times 30 is 240, so that's equal. 30 times 24 is 720, 20 times 36 is 720. By the transitive property, okay, by the transitive property, all right, you don't need to check the first and the third because they're all equal. What's up, Bert? So these can be in any order, or you can flip it. Flip it, it's fine too. All right, but that justifies it. Okay. Or like we said, we can reduce. They all reduce down to 3/2. All right. Now number 3. Okay, number 3. Once again, we got a shared angle in H. So we got to check side lengths 50/75 and see if that is equal to 40 over the whole length, which is 60. All right. They both reduce down to 2/3. So we are certainly good to go. So that would be side angle side. Eventually, when we deal with triangles and parallel lines, you're not going to have to check the whole thing. You're just going to compare the 50 to the 25. But they would have to tell you it's parallel first. All right. And then we look at number 4. It seems to be they're only giving us angle measures. All right. So basically, we would use triangle angle sum. 76 and 48 is 124. Subtract that, and J is 56. Everybody good with that part of it? Do you see a 56-degree angle in XYZ? Nope. And I think there's already 2 angles that are different. Therefore, no. Angles not congruent. All right. Okay, now proofs, which we will talk in great deal about on Monday because it'll be this should get you through hopefully at least the homework, but we'll deal with more on Monday. All right. So it says PQ equals 3/4 PR, PT equals 3/4 PS. Prove triangle PQT is similar to triangle PRS. All right. All right. There's one of 2 ways to prove sides are proportional. One is actually plugging in the numbers. 2 is when they give you the relationship. All right. They've given us the relationship, and that relationship is the same. So basically, we turn around and say PQ over PT equals PR over PS. And basically, you can simply write anything you want that involves the word proportions. Doesn't matter to me. All right? You can put properties of proportions. You can put sides proportions, whatever you want to do. You can just put proportional sides if you want. That's the only idea. All right. Now, same as above. You should hopefully recognize it's probably going to be common. Angle P is a shared angle. So angle P is congruent to angle P by the reflexive property. All right. And then we can say triangle PQT is similar to triangle PRS. SAS. And again, you don't have to document between postulates and theorems. those. Not as big a deal as it was with the all right. Yeah, that should get you through the two proofs that are in the homework. The other one involves mid-segments, which we talked about yesterday, and you would use the same thing. So, for example, I'll put it in on the side. All right. So if you use mid-segment, because this isn't the proof in the homework, all right, I'm going to make that AB, that CD, that E, and that F. All right. A, B, F, or midpoints would be given to you. Would be given to you. All right. You would then say AB is what fraction of CD? 1/2. All right. BF equals 1/2 of EC. All right. Properties of mid-segments. This is the only time it won't be given to you as a fraction, you know what I'm saying? So oftentimes they'll give it to you as a fraction. Properties of mid-segments. And then you would write AB over BF equals CD over EC. All right. And again, proportional sides as well. Good. That takes us to indirect measurements. All right. Indirect measurement, the process of finding lengths that are difficult to measure directly. Two specific situations we'll address. Number one, the shadows objects make. Everybody's pretty good with that one. You've seen that before in your life. A building makes a shadow, you make a shadow, everything's proportional. The second one is this, using reflectors in a mirror placed between a person and a tall object. All right. Now, since we don't have our books, let me show you what that looks like. And you can put this down on the bottom of that page. There should be room down there. All right, so what that looks like is this. All right, here's the mirror. Here's the mirror. All right. You look and basically what accounts for the center of the mirror. And you see the top of another object. Okay, and you see the top of another object. All right, that's the person's height. That's the distance they are away. All right, so I'm going to call it H1. I'm going to call this D1. All right, now I'm going to come over here. That's going to be H2. That's going to be D2. All right, it's proportional. So H1 over D1 equals H2 over D2. Or if you're more comfortable, H1 over H2 equals D1 over D2. All right, that's the major new one. So if I look at 6, explain why the triangles are similar, then find the distance represented by x. All right, so I have the right angle, correct? And then I have vertical angles. So I got 2 pairs of congruent angles. Everybody good? So that's going to tell me they are similar because of what 2 letters? Angle, angle. All right. Now I'm going to take the 2 distances that correspond. 50 feet is, that point is 50 feet away. That point is 80 feet away. All right. With the 50, the corresponding perpendicular is 30. With the 80, the corresponding perpendicular is x. All right. And then you're just going to solve for x. All right. Myself, I would cross out those zeros because they cancel out. 8 times 30 is 240. 240 divided by 5 makes x 48. All right. So keeping that line of thinking, work on number 7. Sweet 16. Okay. A couple things. I know a couple of you asked about this yesterday. When you're just problem solving, they're not asking for scale factors, so it's fine to leave that as a decimal. Right? We talked about that yesterday doing that. Now you can leave it as a decimal because they're not asking for scale factor. Number 2, and this is going to be important in problem solving later on. All right. Oftentimes, ladies and gentlemen, we're going to have problems where that's called the incoming angle and that's called the outgoing angle. Those angles will always be exactly the same. So if you hit an object, so if you want to hustle some money, play mini golf this summer, if you hit an object into a wall, it's going to come out at the same angle. Incoming, outgoing. All right, just so you know. And we'll introduce problems like that with those vocab so you're familiar with that before we take a super duper long quiz on all of chapter 7. Okay, a 1.6, I was about to say million tall woman. A 1.6 meter tall woman stands next to the Eiffel Tower. At this time of day, her shadow is 0.5 meters long. At the same time, the tower's shadow is 93.75 meters long. How tall is the Eiffel Tower? So at 8. All right. Now this is different in that basically the shadow are going in the same direction. So instead of facing each other, they kind of look like that. The person is 1.6 meters tall, and their shadow is 0.5 meters. All right, I got that right. I didn't confuse the problem. At the same time, the tower shadow is 93.75 meters. All right. If, for example, ladies and gentlemen, these are in different units, you don't have to worry about converting. But these do need to be in the same units. You got me? If they're in different units, then you got to change that up. But if these are in the same units, you're good to go. Those don't have to be. You know what I mean? So if this was like in centimeters and that was in meters, don't worry about it. Okay? And then, so we're trying to find the height of the Eiffel Tower. So that's our unknown. All right. So we would do 1.6 over 0.5, perhaps, equals h over 93.75. All right. 1.6 times 93.75 divided by 0.5. 300. Meters?
Yeah.
Really? All right. Let's take a look to see how accurate that is. I'm a little suspicious of that. Seems pretty accurate. We're going to check. They might have just been estimated. We'll talk about that next week as well. It says it's 1,060. Yeah. About 984 feet. Yeah.
0.5 is like a third of 1.6. 93 is like a third of.
The math, it's just how accurate that is, how tall the actual Eiffel Tower is. But that's what I'm saying. So I just looked up. So it says the Eiffel Tower. And like I said, we'll talk about this next week with percent error to prepare you for science and other things. That's what I'm saying. In meters. So give me feet. Okay, the tower is 324 meters. Okay. So we'll talk about that next week in terms of percent error and that kind of stuff. All right. So everybody's good with shadow problems? Seen them all your life, I think. Okay, everybody. Oh, I thought the 6 was half of the line. What do you look? Huh? Okay. All right. Somebody's good? Okay. So let's talk a moment about the next section, 7.4, similarity in right triangle. All right. We're going to take our time with this. We'll start it today. Whatever we get through, we get through. All right. So similarity in right triangle. So let's start with the theorem itself. The altitude to the hypotenuse of a right triangle divides it into two triangles that are similar to the original triangle and each other. All right. For those of you that don't know, the altitude is just another word for perpendicular. It's the height of a triangle. You probably used it before with areas. Perpendicular from a vertex to the opposite side. Okay. So now the math behind it is this. All right. And you have it in those angles. I just want to show it to you. So you don't necessarily have to add these diagrams, but I want to show you where those numbers come from. Okay. So we start with a triangle. All right, and it is A, B, D, D. Okay. And let's say that's what an altitude looks like. It's perpendicular, and this is also a right angle. So you got two right angles in the diagram. All right, so we're going to make this a number, 70 degrees. All right. By properties of a triangle, then this one has to be 20 degrees. By properties of complementary angles, then that one's got to be 70 degrees. And properties of triangles, that one's 20 degrees. Okay? So if you want to put in those numbers, if that's helpful for you, that's fine. All right, so now this is what we have. We have triangle ABC, the bigger triangle, the big triangle, we'll call it. Okay. So we have ABC. We transfer angle measures over 70, 20, and 90. Now we look at the smaller one to the left underneath it, all right, and that's triangle ACD. All right. This is still 70. That was 20. You'll notice those two triangles are similar. Because of what? Angle, angle. And then finally, if we add the one to the right, all right, that's the 90 degrees, that's the 20, and that's also 70. The thing that you want to keep in mind is triangle inequalities. The longer side is always opposite the biggest angle. All right, so the hypotenuse is always opposite the right angle. Then you have a long leg and a short leg. And that's going to be the case in all of them. All right, so in other words, here, the hypotenuse, the long leg, the short leg. Here, long leg, short leg, hypotenuse. That's what personally to me helps me keep everything together. All right. So if I take all the hypotenuses and list them from left to right, the hypotenuse of the big triangle is AB. All right. The hypotenuse of the smaller triangle to the left, AC. The hypotenuse for the one to the right is BC. All right. If I take that and put it over the short leg, well, that would be AC in the big triangle, because that's the short leg. AD in the left triangle, for lack of a better description. All right. And then CD in the right triangle. And you can do the same thing with any of the sides. So you can establish the same relationship between the hypotenuse and the long leg. Same relationship between the long leg and the short leg. So you have three different sets of extended proportions you can set up. All right. I'm going to give you, I always use numbers because it's 20 times easier for me. I would strongly suggest you use numbers. All right, because to me, this is hard for kids visually. This is one of the harder things we do, to the point where I have to actually do the homework myself, make sure I can explain it to everybody. It's hard. All right. So if you struggle, all right, if you struggle with figuring out which ones are which, do yourself a favor, put in numbers. Put in numbers. Okay. put in numbers. All right. So when they ask you to write a similarity statement relating the three triangles in each diagram, that's triangle 1, that's triangle 2, and then triangle 3 is the whole thing. If I take triangle 1, all right, if I take triangle 1, R, S, O, and then basically what I have to do is realize R to S is the short leg, S to O is the long leg. I do the same thing with the other triangles. So if I come down here and do, is that an O or a Q? My goodness! It's time for me to go back to the eye doctor. All right? First mistake all day, 30 minutes. I was doing so well. I was practicing all night to make sure I didn't make a mistake. All right, meanwhile, QST, everybody good with that order? Is similar to triangle. Now I got to do the big one, which would be RQT. Which would be RQT. All right, so do me a favor, do the exact same thing with number 8. All right, do the exact same thing with number 8. We got 2 colleges in there. We got West Virginia and UVA. Very proud of myself. You may have a different answer, but your answer may still be correct. All right, it's very hard to go through that. What's up, man? Nope. As long as they match up. So in other words, for this one, I went a different order. So in other words, WVU is hypotenuse long leg. So as long as you stay consistent with that order, that's fine. So basically, when you submit these as homework, next week when you get the answers, that's going to be tricky for you to see. But when you submit it on a quiz, each one, I have to literally follow your order each time. So when I grade this, I'll look at your first one and go, okay. So you can put the first one in any order you want. I'm going to tell you how I grade it. So WVU, I go, okay, WVU, I would write down hypotenuse, long leg, and then I do the same thing with all of them. As long as you're in the same order, you're good. All right, so you can go short leg, long leg, any order you want. So your answers may be different. They just may not be that. All right? Can't see my answer. Well, listen! Rack knuckles. Okay. The last thing of the day. The last thing of the day. Geometric mean. Given numbers A and B. The geometric mean of A and B is a positive number x, such that A over x equals x over B. Given numbers A and B, the geometric mean of A and B is the positive number x, such that A over x equals x over B.
Mr. Strata,
Yes.
we couldn't see number 5. We can only see
And again,
half of it.
I just typed in what I said to you. From time to time, when you're at home, when I'm giving directions orally, okay, you're going to have to pay attention because there's people just turning on their computers and walking away and not actually participating in class. So I understand you didn't see number 5. I gave it to everybody orally, which means you have to pay attention. And I get that that's hard for some people. So you're then going to have to go back and watch the video because it's in the video. Okay? I just explained that. I typed it in. All right? That's why I typed it in. So that A over X equals X over B. All right? If my mic isn't on, that's a different circumstance. But there's people out there I know, and I'm not pinpointing anybody, who are putting on their cameras and then just walking away. So rather than have you force you to put your camera on, instead, from time to time, there will be oral instructions given. That's all. All right. So to finish up for today, it's basically the square root of the product of the numbers. It's basically the square root of the product of the numbers. All right. So to find the geometric mean of 6 and 15, all you're going to do is what with 6 and 15? Multiply them together. 6 times 15 is 90, and then you simplify the square root. Square root of 90 is 3 root. And that's where we'll pick it up on Monday. All right. And there's number 5 for people who didn't get that, all right, before. All right, so have yourself a great weekend. If you want to get 7-3 practice done, that's great. If not, realize that's due on Monday. On Monday, we'll pick up where the geometric mean is. Have a great day. And have a great weekend, guys. Be safe. Thank you. You too. Sorry, what? Physical copies of the homework? Come on. I give you 7. Be good, guys. Stay safe.